Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on AC and rectification from March 2021, Paper 4, Variant 2. In this class, we will discuss some very important concepts about alternating current and rectification. And those concepts are most frequently asked in past papers. For question number 10, it is given to us the output potential difference of an alternating power supply is represented by this. V is equal to 320 sine of 100 pi t, where V is the PD in volts and T is the time in seconds. For part A, we need to determine the root mean square PD of the power supply. So first of all, we need to write down the general equation for this. Means V as a function of time. This is equal to V naught, means the peak voltage, sine of omega t. Now we have to compare these two. If we compare these two, in this case, V naught is equal to 320 volts. And omega we can also get from here. So omega will be equal to 100 pi. So this is value of omega. We need to calculate root mean, means VRMS. So simply we can say VRMS. This is equal to VP, means the peak value of voltage potential difference divided by root of 2. Peak value is given to us. This is equal to 320 and this is divided by root of 2. So if we solve this one, our final answer will be 226. So the final answer will be 230 volts up to 2 SF. Because the given data 320, this has 2 SF, so the final answer we can also write up to 2 SF. And this question has only 1 mark, answer mark. If your answer is right, you will get this mark. Let's move on to part B. For part B, we need to determine the time period of the output. What value of omega we have? Omega is equal to 100 pi. And omega is also equal to 2 pi over t. Means this is the formula to calculate omega. We need to find value of t. So we can simply say t will be equal to 2 pi over omega. Now simply we need to plug in value of omega. Omega is equal to 100 pi. So we can cancel this pi with this pi. We left with 1 by 50, or simply we can say this is equal to 0.02 seconds. So this is our final answer. This question has 2 marks. The 1 mark you will get if you have written omega is equal to 100 pi. So this is 1 mark, you will get C mark. And the second mark is answer mark. If you have got the right answer, you will get second. For part C, it is given to us the power supply is connected to resistor capital R and a diode in the circuit shown in figure 10.1 as it is given in this figure. For part C1, we need to state the name of the type of rectification produced by the diode in figure 10.1. So first of all, we will sketch this, means V against time if there was no diode in this circuit. So we will sketch how V will change with time across resistor if there was no diode. So this will follow sinusoidal curve somewhat like this. So we will just draw 2 cycles. So this will follow sinusoidal curve somewhat like this. So this is when there is no diode in this circuit. But if there is diode, then how current will flow, means how voltage will change. First of all, imagine that if this terminal is positive, this is negative, so current will flow like this. So this is connected in forward biased, so means current can flow. So this is connected in forward bias, so current can flow in the circuit. So there will be potential difference across this resistor. After half cycle, when this become negative and this become positive, so current will flow like this. So if you look at this point, now this diode, this is connected in reverse bias. So it means that half of the cycle current cannot pass through this circuit. Means current will be blocked due to this diode. So first half current will flow, but in the second half there will be no current flow. Mean there will be current will be blocked. So we will see this curve. We will see this curve. So in this case, we will see this curve instead of sine curve or sinusoidal. And this is half wave rectification. Means only half of the cycle current can flow through this resistor, and half of the cycle current is blocked by this diode. So this is half wave rectification. So simply we can say this is a half wave rectification. So this is half wave rectification, and let me show you the final curve how it will look like. So this is how the final curve will look like. So simply we have to write down this is half wave rectification. So type of rectification, this is half wave rectification. This is half wave rectification. We also have full wave rectification. This question has only 1 mark. So if you have written this one, you get 1 mark. For the second part on figure 10.2, we need to sketch the variation with time t of the PD VR across capital R from time t is equal to 0 to t is equal to 40 milliseconds. But for this question, we have value of peak voltage across resistor. Peak value is equal to 320 volts. We have also calculated time period that was equal to 0.02 seconds. We can convert this one into milliseconds because here we have unit of time that is in milliseconds. So simply we have to divide this one by 100 and we need to multiply by 1000. So we can get answer in millisecond. So the time period in milliseconds is equal to 20. It means that in 40 milliseconds we have 2 cycles, or we can say after every 10 milliseconds there is 1 half cycle. So here we have half cycles. First of all, let's try to sketch the sine curve, means sinusoidal curve. Then we will sketch half wave rectification curve. As value of peak voltage is equal to 320, so we can mark the peak value. In 1 half cycle we will have 1 peak value. This is 300, so here we will have 320. So we can mark 320 halfway between 0 and 10. So here we will have first peak value, and the second peak value we will have somewhere here. So this is, and the third one we can also mark, that one will be here. So this is the third peak value, and the fourth peak value we will have here. So here we will have fourth peak value. First of all, we will sketch sine curve only. So this is how we can sketch the first sine curve in the first half cycle, and in the second half cycle this is how we can sketch. So this is in the second half cycle. In the third half cycle, this is how we can sketch. This is not the final answer. This is just sine curve. And in the fourth cycle, this is how we can sketch. But this is when there is no diode in the circuit. But in this question, there is a diode that is connected in the circuit. So it simply means that this lower half, there will be no current passing through the resistor. So simply we can clean this one. There will be no current passing through the resistor, and in this half also there will be no current. So the final shape of the curve, we will see this one. So this will be final shape of the curve, and this is half wave rectification. This is how we need to sketch. If we sketch this one, we will get 3 marks. So the peak value has to be correct, time period has to be correct, and the shape of the curve also has to be correct. So you will get 3 marks. For the last part on figure 10.1, we need to draw the symbol for a component that may be connected to produce smoothing of VR. So first thing we need to understand what kind of component we need to connect. We need to connect capacitor in this case, capacitor, because capacitor can be used to store energy. So we need to connect capacitor across this resistor. So this is how we need to connect capacitor. This question has only 1 mark. If you have drawn capacitor in parallel with this resistor, you will get 1 mark, and that is B mark.